audio, video, and cameras. In this nugget, we take a look at audio, video, and cameras. We start off by taking a look at audio, and although we visited that in the past, we look at some more details about audio, such as some of the additional connectors and various ports that you can use, and digital audio as well. We take a look at video, such as the display types that are available. We look at the various types of connectors that can be used to connect a monitor, and we'll listen to some of the terms that you might also use, such as weird ones like degaussing. We'll look at webcams as well and check out their basic operation. And then we'll finally conclude with digital still cameras, which are increasingly growing in popularity. Alright, now we've talked about sound cards in the past, but let's get a little bit more specific about some of the audio characteristics of some of these types of devices. First of all, the simplest way to go is just to use the ones that are integrated into the motherboard, and we've seen the back of the motherboard before. We have a lot of those different connectors. In the past, it used to be that the ones that were integrated were really not that good. They were just simple analog, and you might get stereo sound out of them, and that's pretty much it. But nowadays, the sound that comes out of the back of the motherboard on higher-end motherboards is actually pretty good. So you might want to just go ahead and stick with the simple stuff and the easy stuff and use what's already there. Otherwise, you could get expansion cards, which we've discussed before. Now, most audio is going to be what we call Sound Blaster compatible. I mentioned that before as well. That's just kind of a de facto standard devised by the Sound Blaster as a branding of CreativeLabs.com. Now, also, most audio is also analog by default. So if you just plug in one of these kind of jacks, like this right here, if you just plug one of these into the back of your computer in the green port, that's normally how they're colored, then that means you're going to get stereo sound out of this. And I can tell you're going to get stereo because it uses two rings right here on this 1/8" jack. Anytime you see two black rings like that, or two ringed areas, that means that it's going to be available in stereo, meaning that it comes out of the left and right speakers independently. Whereas this would be a mono 1/8" jack, and you would get the same sound out of both speakers instead of different sound independently out of each speaker. Now, in addition to the standard ports that you see back there, you'll also have an additional an input, which is normally pink in color. I'll show you that in a moment. An output, which is for your speakers, and you may also have a line in here. I should put line in there as well. This would be so that you could plug in, a CD player or some other kind of a device and have it as an input into the sound card that you can then record with, for example. And if we take a look at the motherboard rear connections, we can review those just briefly here. Again, the green is normally going to be output. Normally your speakers plug in there. A lot of the speaker cables now are also color-coded to match this. Pink is usually your input for something like a microphone, and then this would be the line in. These are the three that you'll see on most motherboards. You might not see these other three, but you'll usually see at least these three. And this would be the import, like I said, for something like a CD player or a tape deck or something else where you wanted to put sound into the motherboard that you could then record off of. Another thing to keep in mind is that if you work with higher level sound devices, then they're going to also offer digital. By default, everything's analog. Even these high level devices, by default, are going to use analog out. However, you have the ability to use digital. In order to use digital, you'll have to use the right connectors and you'll have to plug into the right ports. Let's go ahead and take a look again at the back of the motherboard here. If I wanted to use digital here, then I would have to go over here. I could use one of these two options. This one is coaxial, and even though it doesn't look like the coax cable that comes out of the back of your television, and it's not, it's a different kind of a connector, it's an RCA connector, it is actually a digital signal that's going to be passed through this. The other thing that I could use would be optical, and this has this kind of a gray swinging door that flips shut anytime I don't have a jack in there, or anytime I don't have a cable in there. But this one actually uses light transmissions to send digital signals out to some other device. So, for example, with either one of these, I could plug a cable into this, and on the other end of either one of these cables, I could plug it into my home stereo system or any other audio device, high-end audio device, that would be able to use and appreciate digital sound. Also, if you do use any of these kind of digital interfaces, then you might also need to use some kind of a software utility that maximizes those or configures those. For example, my motherboard's from Asus, and this is the utility that they have. So if I had some kind of digital out, then we could use this SPDIF, that's Sony Philips digital interface, and we would just then be able to configure it. I don't actually have anything plugged into that right now, so it wouldn't make any sense to actually use that out for the time being. And although it's not my job to show you everything about this software product, this is the basic idea that if you want to use the digital out, you'll have to use some of these functions here within the software program that they give you to make that work. And then let me return back over here to the right-hand side, because there are a few other sound ports that we haven't ever addressed yet. One of those is this orange one. What in the world is that about? That is if you have a subwoofer. You would plug that into it, and that gives you a deeper bass notes. You may also have surround sound, in which case you might want to use this black item right here, and that would give you the rear speaker. So if you have a speaker behind you, or if you have enough speakers, that would send the out to the rear speaker. And then this gray one, it kind of looks white in the picture, but it's actually gray in this photograph anyway. That would be side speaker out. So that would give you the ability to use multiple audio channels. You could have your left, right out of your stereo and a subwoofer, and then you could have a rear speaker and side speaker. So you could get kind of a surround sound experience. A lot of the devices nowadays, by the way, let me get back to my little whiteboard here. A lot of them nowadays also will give you the ability to use 5-to-1 or 7-to-1 sound. I mentioned earlier SPDIF. That's Sony Philips Digital Interface. That's one of the kinds of connectors that you would need to use. And you can also use coax cables, as I mentioned earlier. And then again, you can get subwoofers as well. There's also something called MIDI. What is that about? Well, for that I'll have to take you to a different photograph. Here I've just gone to a product photograph from Creative Labs, and I'm not trying to pitch Creative Labs. They just happen to be kind of the most noted players in this whole field. And this is a device that they have. This one in particular would be what we call an add-on module, and this would then go into an external drive bay that allows you to then plug in various devices into these things and be able to use them. If you have RCA cables, then you might have this left and right inputs right here, something like these. That would correspond to a cable much like this, where you would put the red in the red jack right here, then you put the white in the white jack. By the way, red is also the right channel, and white is always the left channel. The way I always remember that is red and right both begin with R, so that helps it make it easier for me. Some devices may also use video, such as the back of a video cassette recorder or something like that. That'll normally use a yellow video jack, and that's the standard coloring for these three types of jacks. This shape of a jack is an RCA jack, and you wouldn't want to get that mixed up with the coax cable that I showed you that you would plug into the back of this. Okay, let me get back over here. Okay, you wouldn't want to plug any of those cables I just showed you into this, because the resistance is not the same in a coax cable. Even though the connector is the same, the resistance is not the same, and you're not going to get the results you want. So make sure that if you do plug something into that one, that you use an actual coax cable. And then here we have some additional, inputs and outputs. And again, for this one, we could use coax. This is a Sony Philips Digital Interface. These are all coax items. This would be a headphone jack that you could plug into. This would be a microphone in. This is the volume that you can adjust for the microphone or the sound right over here, the output. Here's optical in and out, okay, that we see right here. And then this is what we were talking about earlier, MIDI. What is MIDI? Let me clear that off so you can read it. MIDI is Musical Instruments Digital Interface. And what that is in this device or in the operating system or somewhere, there are actual recordings of actual instruments that you can use in composing music. And so then you can take those instrumental sounds, which are literal, real sounds from true instruments, and then you can plug these things into a keyboard of some kind, and then you can integrate those musical instruments into the composition of your music. And then some of these devices will also have, you can see some pins back here. There'll be a cable that goes from this device right here that goes into an empty slot, probably into these pins here as well, and you can then connect the two together. And then this here is an optical cable, and you can see it has a kind of a unique shape to it right here. You can only plug this in one way. Once again, you can't get this backwards or anything like that. I took this picture a little bit darker because I wanted to show you that there's light coming through this. On the other end of this cable, which is exactly the same shape, I was shining a flashlight through. This is an optical cable where plastic or glass is the core of this, and therefore it gets very clean digital transmission. And this connector here would go into, right over here, this particular port right here on the motherboard. And it's the same kind of thing you'll see on the back of high-end home stereo systems and the like. And then here's probably a little bit better look at it right here. I don't have the flashlight, part of it there, but you can see a little bit better picture of the actual connector itself. Do be careful with these because sometimes this is glass or plastic might be a little bit exposed, and you wouldn't want to drop this or hit it on the edge of a desk or something and potentially damage the end of that. Some of these come with a little rubber piece on the end that you only take off when it's actually time to use the device. And then here we have a photograph of a coax cable. They don't all have this kind of, cut gaps around the outside perimeter of this RCA connector. Not all brands do that. Monster does. What happens is they actually are able to make this a little bit tighter, but because of these gaps, it's not going to be bound to the RCA jack. You're going to be able to twist this and pull it off still if you need to. And then you can see how that looks, and that would then go right over here, okay, right in this orange connector right there. And again, the same kind of cable can be used in the back of high-end stereo systems and the like. Now let's take a look at some of the various display types that you're likely to see from your customers. There's actually really two. One of those is a CRT, or a cathode ray tube. This is just an awful lot like a television, where the older televisions, not the flat panel plasma or LCDs that we have now, would have a curved front, and then they would be deep. So it could be even, 18, 24 inches or more from the front of the television or CRT to the back. And again, I'm kind of using CRT and television and computer monitor all the same in terminology here because they really do the same thing effectively. But at the back of this would be an electron gun right here, and it would have some combination of red, green, and blue. And so then having filled all of that in there, we have red, green, and blue projecting through here, but it's not just in some haphazard fashion, otherwise you won't get much of a picture. There's other focusing techniques that take place in here, and alignment, certain kind of alignment screens and so forth, that can specifically direct whatever combination of colors are necessary here through each individual pixel on the front of the screen. And you know what a pixel might be? It's if you walk up to the television real close and kind of stare at it, you can see the tiny little circle of light that comes through that. And don't look at it too long or too hard, because that's one of the things that your mother told you would make you go blind. But when you take a look at this, you'll see each individual little pixel. Also, with a CRT, it does have a refresh rate, so that it will refresh from top to bottom so that it can kind of redraw the screen. That's how you get your sense of motion. If it had a static image on it, then you can only view it like still pictures. So the fact that it uses motion, it'll have to refresh from top to bottom in order to display that type of thing. And this is usually referenced in hertz. So if it had, 60 hertz, for example, if I can spell here, 60 hertz, then that would mean that it would refresh 60 times per second. And that would be somewhat imperceptible to the human eye, although some people have told me that they do get headaches at that, and so they might have to kick that up to 70 or something like that. Again, to me, it's not visible, but some people might complain about it. So anyway, it does refresh, and it is a heavy device. I mean, these things can weigh probably 30, 40 pounds, depending on the size of the monitor you got. I had a big one that was often used by graphic artists a few years back, and it was very, very heavy on my desk. Every time I'd set it on the desk, I could just hear the desk kind of make a creaking noise, like it was going to cave in or something like that. Kind of like when I sit on my chair after having eaten all my food at Thanksgiving or something. Anyway, it's got a large footprint here as well, and that's largely because of this distance from front to back. Okay, because you see, what happens with this is, since the electron gun needs distance from the phosphorus coating on the rear of this screen in order to be able to give the image that you want, well, normally the light is going to, of course, spread as it goes forward. So the larger the front area that you need, the further back this electron gun needs to be as well. Now, there's certain things that manufacturers have been able to do to tune that and to help somewhat compress that space more than they would have had to normally, but you're still going to have a lot of space there, so for that footprint. And if you're in a small cubicle with a very shallow desk space, you probably would have had to put a monitor like this in the corner so that you could make use of the corner space there. And also, these typically use a VGA connector. And here's just a photograph of the VGA connectors, both the male side and the female side. Normally what you're going to be doing is you'll plug in the female side into the monitor itself, and then the male side you'll plug into the back of the computer or the back of the video card, what have you. This is a 15-pin connector, which at least at first glance, it looks an awful lot like a standard serial cable because it's a smaller D shell, but it does use more pins, so keep that in mind. Speaking of pins, by the way, I just happened to notice this. I might have messed this up. At some point in the past, apparently I have bent this pin over a little bit. I don't know if you can tell, but it's shifted a little bit this direction. Okay, and one thing that I want to tell you about is if you have any of these kinds of cables, whether it's VGA, serial, parallel, whatever, and you have some pin misalignment like that, easy way to straighten that out is potentially with needle nose pliers. I generally actually tend to prefer a flat head jeweler's screwdriver, and I just exert a little bit of pressure in the opposite direction here to push it back over where it was supposed to go. If you do fiddle around with that too much, it could potentially weaken the pin or compromise its integrity down towards the base, but normally it's okay if you have to move it just a little bit. Also with these VGA connectors, the older connectors were really a hassle. You can't really see it in this photograph, but at the back of this one are thumb screws that you can just use. It also has a slot in the back of that thumb screw, so you could use a screwdriver if you wanted to. Some of the older ones only had really tiny metal screws that you would have to use, and you couldn't use your thumb to tighten it down. You'd have to use a jeweler's screwdriver, and they're pretty much a hassle. VGA connectors like this can still also be used, by the way, in other types of monitors, such as LCD flat screens. Most of them now have an interface for this or another kind of connector, which I'll show you in a moment. Or you can also use these kinds of connectors very frequently for projectors, like we use in conferences and the like. And then you're also likely to see LCDs, or liquid crystal display types of monitors. This is the same technology that's used for LCD televisions, and it's what you're going to see with any new computer that's purchased these days. What happens with this is that it uses polarization, and it does this through two filters. One filter will just change all of the, or actually block all of the light waves. It works at a right angle to block those waves. And then there's a second polarizing filter, which is actually the liquid crystal display part of this. And these things will flow like liquid, but they're actually little crystals, and they will focus to each pixel in the screen. Each pixel is again composed of red, green, and blue. And so, for example, here you might see each pixel with some combination of red, green, and blue in it. Now I'm going to use the power of Photoshop to kind of illustrate that for us. If we had the polarizing screen was sent to us as some combination of red, green, and blue, well, at this point, you know my pen color right here? It's pure red, isn't it? Well, that's because my red is cranked up all the way to 255. If we had, however, some other combination, let's say it was 90 or 102, and then green was 184, and then blue was 99, then we would see this color, whatever that is, some kind of a nauseating looking green. I did a really good job there, didn't I? Well, both the CRT and the LCD pretty much do the same thing. They will adjust the combination of red, green, and blue to give you some different kind of a color, or some kind of a purple, or whatever it is that you want to have. By the way, you may have also confused this a little bit with something else. People get this mixed up all the time. They say, well, I thought it was supposed to be yellow, cyan, and magenta. I mean, my printer uses yellow, cyan, and magenta inks in my inkjet printer, so how come we're talking about red, green, and blue here? Anytime you are projecting with light, for example, through a monitor where it's illuminated, then you use red, green, and blue. For print products like magazines, books, and a print that you make off of your printer, where light is reflected off of the surface of that material, then you use yellow, cyan, and magenta, and by the way, it's also usually black as well. And then some combination of those colors will create the color that you want for a reflected surface. So anyway, it's those polarized crystals that create that combination of light. And then we'll also get, with an LCD monitor, a much lighter and smaller footprint. Just like your LCD televisions are flat screens, so are these LCD display types for our computer monitors. And they're also going to generate or require less power, and they'll generate less heat as well, so you have those advantages. Let's also take a look at some of the various video terms that you might hear related to displays. One of those would be resolution, which is a little bit of a misnomer because it kind of implies that you can actually change the pixels of the monitor. You can't do that, though. They are fixed in size, but you can change the perceived resolution of the monitor. Probably a more accurate term would be to say pixel dimensions. Anyway, I have a table about that I'll show you a little bit later. And then there's also native resolution. But let's go ahead and take a look first of all at a monitor. I don't know what I drew there. It's kind of crooked. It looks like Nebraska or something. Hopefully your monitor doesn't look like Nebraska. Anyway, a common resolution that you'll see, especially on older machines, might be 1024, and that would be the width. okay, by 768. And that would be the height. That would mean that I have 1,024 pixels from left to right, and then 768 pixels from top to bottom. And then if you wanted to multiply all of those out in total, then you would see that you have 1024 times 768. That means I have 786,432 individual pixels on this monitor. All right then, now what about this native resolution that we see here? This is whatever your literal pixel dimensions are in the monitor that are hard fixed pixels in the monitor. But it's possible for me to trick the monitor into showing a different display resolution. For example, I could back it down to 800 by 600 or 640 by 480. Or I could increase it to 1920 by 1200. Key things to keep in mind with that is, number one, you can potentially damage your display, especially on a CRT, if you go out of scope for whatever it's specified to be able to handle. And that the same would be true if you adjusted the refresh rate, especially on a CRT, to be higher refresh rate than it's designed to be able to handle as well. You can just totally ruin that monitor. So be very, very careful of that. Also, if I were to do something like increase it to 1920 by 1200, well, it's going to have to kind of trick the pixels into displaying that, and it's not going to be as sharp or as good of an image if I had a native resolution on the monitor of 1920 by 1200. By the way, I've also got a PDF file for you here, which shows all of these various resolutions that we've been discussing, and most of these of which are also identified on the A+ exam objectives. The top two are not actually on the A+ exam objectives, but they're so common and so frequently seen in a lot of different places. For example, projectors as well in conferences and so forth. Many times presenters will still use 800 by 600 because it allows the lettering of whatever documents they're showing and stuff to be more visible. I mean, their native resolution might be something further down here, but for the audience, the letters are so small at those resolutions and so fine that they're difficult to see and people have to squint at the screen. So that's one example. The other thing is, these last few that we see down here are probably the most common resolutions that you'll see on most monitors these days, and I would just be aware of what each one of these are, and this PDF is available for your reference on nuggetlab.com. Also, take a look at the contrast ratio of the monitor. Now, this is not necessarily important for the actual use of the monitor, but certainly if a customer is asking you for a recommendation, depending upon what they do for a living or what they need the monitor for, the contrast ratio could be important. If it's just for general office work, I usually just buy whatever's cheapest, quite honestly. But if they're doing something for high-end, AutoCAD, or if they're graphic artists or photographers, then I would have to take a closer look at the contrast ratio. The contrast ratio is a measurement between what the monitor is able to display in the range between pure white and pure black. And I say pure, but white where there's still visible detail, and black where there's still visible detail. I mean, if you turn the monitor off, it's completely black, right? Well, we're talking about what's visible detail in this entire range. And the higher the contrast ratio, normally the better and more expensive, by the way, as well. So again, for general office work, it doesn't really matter. But there's a couple of different definitions of this as well. Most of the manufacturers come up with their own dynamic contrast ratio, and this is really just an internal in-house standard that they've come up with to kind of inflate the numbers of their contrast ratio. But the static contrast ratio is a more honest representation and one that all the manufacturers would have to hold to on the same standard. So, for example, I'm a photographer. If you've seen any of my videos before, you know that I do a lot of photography, and I do some work for a division of CBS Sports, and do a lot of other kinds of photography. So that's pretty important to me to get a good monitor, because I have to have a real accurate view of the photograph that I'm trying to edit, for example. Another thing to keep in mind with this, I don't have it on the whiteboard here, but just another term to throw at you, and that is calibration. Again, depending on who your customer is, that's supposed to be a B there in the middle. Calibration. Depending on who your customer is, this can be pretty important. Again, if it's just general office work, who really cares? But if they are, again, a graphic artist, a photographer, somebody like that, or if they're doing desktop publishing and the like, then you need to make sure that the monitor is properly calibrated so that it shows accurate color and brightness. So for example, what I see on the screen here is some shade of purple. But if your monitor was not calibrated properly, this might look like some shade of blue. Purple and blue, that's a fine line sometimes between those two in photography and stuff. So I'd have to make sure that I calibrated it properly. And there's a number of different devices out there. I use a Spider 3 Pro, but there's also Greytag Macbeth products and a number of different ones. Just Google for calibrate monitor and you'll see a number of different products that do this. And they cost anywhere between $100 to several $100s if you get one that will also calibrate the output for your inkjet printer. And the design of that is so that whatever you see on the screen, the colors and the apparent brightness of the image should turn out to be exactly the same or as close as can possibly be on the actual printer when you print them out. Also take a look at the refresh rate of the monitor, which we discussed a little bit a moment ago. This is, again, normally going to be automatically selected for your LCD monitors, so that's not usually as big of an issue as it is for CRTs, where it could potentially damage the monitor if you go outside of its specified scope for the refresh, whatever it can accept. Also, take a look at multi-monitors. This is also known as dual-headed or two-headed displays. And this is actually what I use right now. And in fact, I'm running Windows 7 on my own computer, but I'm going to just go ahead and show you the interface for this. This is very similar to what you'll see in Windows Vista and Windows XP. And what we can see with this is I got two separate monitors going on here. And in fact, if I click Identify, we'll see that right now I'm recording on the second of those two monitors. It's kind of big there on the screen, but I'm recording on the second one. And I can change the resolution for these things as you see accordingly here. And now where it says recommended here, that's exactly what I was talking about earlier when it says the native resolution. It recommends this not only because it's the highest one, but also because that's the native resolution and these are the actual pixel dimensions that I have for these monitors. I think they're like 21.5 inch LCD monitors. And then when you actually decide to use two monitors, you have to determine what you want to do with the multiple displays. You can extend the displays so that, for example, I could drag a window from this window over here, I could drag it over here, and basically, even though it's two monitors, it effectively has the same effect as one really wide screen, as if this whole thing were one big wide screen. But I could also choose to just duplicate the displays, which means that they would both have the exact same image on them. And that's the kind of thing that you'll very often do if your second display is a projector. Again, as in a conference room or in some kind of a presentation or something like this. And then when it comes to degauss, this is another term that you might have heard. This does not really apply anymore to LCD monitors, but CRT monitors, because of the phosphorus and the way the electrical characteristics would appear on a CRT monitor, very often you would want to degauss it. This means to demagnetize, and you don't totally demagnetize it, but you're able to reverse some of the built-up magnetization that has taken place in the monitor. Over time, that can cause the picture to kind of bend or get some kind of weird warping to it. For example, it might pin cushion, which is where it kind of all the corners kind of cave in, or it might pillow, where they all kind of, cave out, that sort of thing, or it might get some other kind of strange warping effect in them. Well, most of the monitors, if you look through the menu systems on the buttons on the monitor, there will be a degauss button, and when you press that, that may help to alleviate this situation somewhat. And then there are also probably additional controls that you can fiddle with that will allow you to do this as well. And it just changes the way that the electron gun and all of the associated components internally will focus the screen. Now let's kind of go through a connectorama of different video connectors that you might see out there. So for example, the first one, and these are pretty much from the lowest quality to the highest quality, probably the lowest quality that you can get in most situations would be an RCA connector. It's just not going to give you as high a resolution or a view as you might see otherwise. But here we have RCA connectors, and I've shown you these in the past. Remember, this one would be for your right stereo, this would be for your left stereo speaker, and this would be an RCA connector for video, and video is usually identified as a yellow connector. This is a lot like what you would see on the back of a VCR, for example, or some other kind of a home theater device. And you'll also see this very often on the back of TV capture cards. You'll see the female end of these male connectors, and they'll be color-coded appropriately. The next kind of connector, we already took a look at a picture of it earlier, was the 15-pin VGA connectors. And then the next one would probably be the S-video connector. And a picture of that one would appear like this. Again, this is kind of easy at first to confuse this with something like a a keyboard or a mouse connector because they look very similar, but they are a little bit different, and they do have a little bit of different indentations in them. For example, this key right here in the middle is going to be different on a keyboard because it appears vertically instead of horizontally, and there's a different number of pins. The S-Video connector has 4 pins, whereas the keyboard or mouse connector will have 6. Let's also take a look at the kind of connector that's going to be most frequently found on monitors and video cards right now. That would be the DVI, which is Digital Video Interface, I, or the DVI-D type of a connector. The DVI video port is going to support both analog and digital signals. On the back of many monitors right now, it'll have a connector for both analog VGA and digital DVI. That's another one of the big advantages here of this type of a connector over something like RCA and VGA. These are both analog types of video output, whereas digital is going to be, of course, more accurate, and it's going to give you a better picture. The DVI-I is capable of both analog and digital. The DVI-D cable is capable of only digital signals. And let me show you a picture of the connector, and there it is. Okay, so they're all kind of at an angle here in this, and you have a blade here that's sideways, but that's kind of the way that those types of connectors will look. You might also have a component connection. Now, and this one, it's not necessarily better than DVI. That's just they're pretty equivalent down here towards the bottom. But the component one will just look like 3 RCA cables, and that's actually the shape of them. But the fact of the matter is, with these, you'll have a green, a blue, and a red. And these are used mostly in home theater types of systems as opposed to PC usage, and this is also going to give you very accurate color rendering, although some of the other color connections are going to be better nowadays, in particular HDMI. HDMI stands for High Definition Multimedia Interface, and one of the examples of those kinds of cables would be just a photograph that I got from Monster Cable, and you can kind of see the shape of this one, flat along the top, and it kind of curves in down here towards the bottom of that particular connector. What's useful about this, and what I like about it, is number one, it's going to give you the absolute best signal. It's also digital, of course. It's going to give you the best signal, and it not only conducts the video signals, but also digital audio signals as well. That's why they're very useful for things like home theater and televisions now, because you can set up maybe a high-end receiver, and it just has a single HDMI cable out of the back of it going into, for example, your television, and you don't have to mess with both video and sound. You have one cable that handles both and handles them both at the highest quality. Now, we talked about video cards at some point in the past, but I want to push in here a little bit and show you a little bit more about something like this one here from ATI. This, again, is taken from ATI's websites where they make their graphics available for download. Here we have the HDMI connectors here. Okay, so we could use that kind of an interface. And then you can see also here that we have the digital video input here as well, their DVI. One of the things that I also want to point out, though, regarding video cards themselves, is that most of the high-end ones nowadays have their own active fan, as opposed to a passive heat sink on them, which just dissipates heat with some kind of a series of fins, for example, or prongs. Instead, this one actually uses a fan, and it may need, in fact, it does need, its additional power source of its own. So you'd plug in a power to the connector, probably out of view here, and then it would blow the hot air out of the back of these vents back here. And then we also talked in the past about the fact that you can use 2 or more video cards at once. But take a look at this monster. This is from ATI as well, with their high-end graphics cards. And again, NVIDIA has the equivalents to all of this. But you can now connect 4 of these together with ATI, and this would be useful for an extremely high-end, maybe even like Hollywood video production kind of a thing that you could have. And we'd have DVI connectors out of here. But again, we would gang these together so that we would have all the video coming out of a single card, for example, and it would get the aggregate performance of all of these cards put together. Again, all through these connectors that daisy chain each one of these after one after the other. Oh, also here on the end of these, I was telling you they need their own power supply. This is where the connector would go for the power, and you'd have to make sure, of course, that your power supply was able to supply power to each one of these as well with appropriate connectors. And then those ATI cards, they use their branding called Crossfire to gang those all together. And as I mentioned earlier, NVIDIA uses SLI. Now, what I want to show you here is not on the A+ exam. It's just my own personal tale of woe. And you have to listen to this. Why? Because I've got a microphone and you don't. And there's not a thing you can do to stop me, folks. Except for turn off the recording. Don't do that. We got more to come, folks. I just want to share with this real quick. And this might be useful in your own troubleshooting as well, by the way. But I had ganged these two together in an SLI connection, and I didn't seem to be getting the video performance that I expected to get out of these connection combinations. And I looked at this video card, and it was working just fine. The fan was spinning just fine and everything. And I had the cover off the computer so that I could observe this. And then I looked at this video card, and this fan here was seized up. It was not moving at all. And if we take a closer look, you'll see that I had to pry up this metal around the fan housing. And apparently this had just they had spec'd this too tight, and the metal and the fan were rubbing against each other, and it had seized up this fan. Apparently it burnt out the video adapter or something like that, so I wasn't getting anything out of it. I don't know how long it had been like that, but anyway, that's just something else to keep in mind and to look out for. Another thing to look out for here, at least in terms of troubleshooting, is there is a connector here for these fans, and that's true of most of the brands. And so if that's come loose or no one ever connected it or something like that, it should come connected from the factory that way. But if it's not, then once again, your fan will not be spinning that way either. Now let's also take a look here at webcams. Webcams, of course, are just those cameras that you can use to display video. You saw me use one earlier when I was demonstrating the USB interface, which is the common connector now for all webcams. This is where I went beyond the 16 feet. It's like 20-25 feet that I used for our connection that I used earlier. Anyway, we have varying resolution with webcams from like 640 by 480, 800 by 600, and right now you can get cameras that also do 720 HD so that you can see yourself in all of your HD glory. Anyway, that sounded kind of creepy there, didn't it? Anyway, speaking of creepy, this reminds me, this is just a quick side note. There's a school district here in the Phoenix area that is sending laptops home with their students. They're owned by the school, I guess. And they have security software on them. And they also include, of course, a webcam built right into the screen at the top of the screen of these laptops. Well, it turns out that they're using the security software supposedly to track stolen laptops so that they can turn it on when a laptop is stolen. They can see who it is that's got this laptop. Turns out they're using it for more than just that purpose. Need I say more? Causing a huge firestorm around here. Anyway, so we do have those webcams that we can use. Now, these will also usually include a microphone so that you can do things such as use your instant messaging software and the like from AOL or who else is there? Yahoo, and a bunch of different other instant messaging programs that will be able to also use your webcam and the sound. And software is required for the output. If you're not using one of those instant message programs, you can also use something like LifeCam from Microsoft. Microsoft or Skype. My daughter has a boyfriend who plays for a really good band, and he's a bass player for them, and they tour the country and stuff like that, and he's based out of Nashville. So they're never together. Maybe I should be thankful for that as a father of a teenager. Anyway, so they are able to communicate using Skype just about on a daily basis. Anyway, by way of demonstration, in case you haven't been able to put a face to a name yet, I'm going to show you my own webcam right here. Ta-da! Using Microsoft LifeCam software. And there I am, folks, in all of my, in this case, I guess it's a 640 by 480 digital glory. I don't know what to tell you, folks, and I just kind of apologize in advance here. They told me I was cute when I was a baby. Not quite sure what happened. Anyway, so that's our webcams. And then here's an example of a webcam. This one's from Microsoft. It's an HD camera capable of 30 frames per second. It also has the microphone built in that you can see up there. And usually there's a button on these things somewhere. That's probably what that is back here, where you can also snap a still photograph through the webcam if you want. Let's also take a look at still photography, and in this case, digital still cameras. Now, this is something that I have a high degree of knowledge about, but I'm not going to try to share everything I know about it because I want to try to stay on track as much as I can. And in fact, some of this might even be more than you really need to know, but I'll be brief as I can. First of all, with the consumer level, I have three basic levels. The first one's a consumer level camera. Normally, these are called point and shoot types of cameras, and they might have kind of a boxy format, something like this, that can fit in a pocket or a shirt pocket or a purse or something like that that's very easy to carry around. They're normally very light, and usually you just push the button, the shutter release, and that's it. You can walk away and go on to the next ride at the amusement park or wherever you happen to be. Some of the common features that you'll see with these is that they will very often have some kind of a zoom factor, meaning that you can push a button or shift a lever or something like that to zoom in and out, which would equivocate to walking closer to or further away from the subject that you're photographing. Some of these might have impossibly high numbers. Instead of 10x, it might say 30x or something like that. Well, very often, that's kind of a fake resolution. What really happens there is, rather than moving the lens elements inside of the camera here to zoom in and out, it will zoom to the maximum that it can with the lens elements, and then it will actually just crop the pixels in camera. So even though you might get 30x, you're getting a lot less pixels with that resultant image. So it's kind of a fake zoom is what I call it, really just cropping in camera. And then you'll have different features from different manufacturers that can vary from one to the next. I'm not going to outline all of those, but you might see here, for example, VR from Nikon. VR stands for vibration reduction, and if you're using a slow shutter speed, for example, if you're in low lighting conditions and you don't want to use a flash or can't use a flash for some reason, then just there's a little bit of a camera shake or vibration that comes about just by holding the camera instead of putting it on a tripod. Well, that could show up in the image as motion blur, and it might make the image not quite as sharp. Vibration reduction will help to mitigate that kind of a situation. Now, these also will have a fixed lens on them. For example, the photograph that we just looked at, there's no way I can take that lens out unless I use a hammer and a pair of pliers or something like that. Don't want to do that. This is a fixed lens that you do not interchange. And, by the way, I might add, these digital still cameras, even the lower level point and shoot ones, are amazingly high quality these days. In the early days of digital photography, they were nowhere near as good as film cameras. They often looked kind of grainy or not very sharp, but the quality of these now is just outstanding, very, very high even for these things. The interface is usually going to be either FireWire or USB ports. So many of these cameras will have both types of ports on them that you can use for for still cameras. Normally, you're going to see a tendency to go towards USB. For video cameras, you're normally going to see more of a tendency to use FireWire instead. Now, when you work with these photographs that you take in a digital still camera, they will normally record to a memory card of some type, and there's a number of different formats, form factors for these memory cards. So how do you get the pictures into your actual computer so that you can look at them? Well, you will have to import them, and this can be done a couple of different ways. Then by way of example, I've put a compact flash card in my compact flash card reader, and there's the drive for it right there. It comes up as drive G in my case. And here's a bunch of pictures. Not really even sure what all of these are here. But anyway, there's probably from a soccer match that I did recently. So anyway, I could press Control A to select them all. Then I could press Control C to copy, or right-click and choose Copy from the right-click menu that we see here. And then I would just paste them into a folder of my choosing. Alternatively, your camera may come with some kind of software that as soon as you insert the card or attach the camera via USB or FireWire cable, it'll automatically detect the presence of that image, of those images, and then offer to import them for you into appropriate folder or directory of your choosing. So once again, you can just manually copy and paste, or you can use whatever software came with your camera. They both do fine. One thing to keep in mind is do not format your cards directly in the PC. For example, if I go back to that, let me go back to that card right here. When you first import these, a lot of times it'll give you a message. And let me try to find it. Let me try to trigger that so that it happens. So I just unplugged the card. I just took the card out. Now I'm putting it back in. And what you should see sometimes is a message. There it is, like this. Let me drag it in here. It looks like this. It seems like there's a problem or something like that. You can scan or fix or continue without scanning. This is really not a problem. A lot of times these camera manufacturers will have their own format for these flash memory cards, and you should not format these so that it fits into the Windows mold, so to speak. This message there related to scanning only because it didn't recognize the format as a normal Windows type of a file format, although it certainly is readable. Anyway, once I've copied the files to my computer, and if I want to empty that card out, do not format the card in the PC because it's not the same format that is required by the camera. Put the card back in the camera, and then through the menu system, or in my case, on my cameras, there's a couple of buttons that you press simultaneously to automatically trigger a format of that card. Real quick and easy. Just don't use the PC. Now, the next level of digital camera that you might see would be something we call prosumer cameras. These are going to be larger and a little bit bulkier and heavier than the common point-and-shoot cameras, like I showed you, those little boxy cameras that fit in your shirt pocket. They do resemble somewhat a smaller SLR. For example, I think I've got a picture right here. This is an example of what we call a prosumer camera. So it looks almost like a professional SLR, except that this lens here is still fixed. You can't really twist that off. some of the more advanced cameras, the SLRs, you can't. However, this is going to give you a higher optical quality and a greater degree of flexibility in how you take the pictures and timed exposures and all these other kinds of things that you might be interested in. Notice that it also has a larger zoom range, 26x, for example, as opposed to 10x. That's because there's a lot greater distance between the front of the lens clear to the back of the lens back here. So the engineers are able to work with the optics in a much greater range of motion, thereby providing a larger zoom range. So as we said, once again, you're going to get something like a fixed lens on these, better optics, and a larger focal range. Also, you'll just get an overall higher quality. The sensors are usually better. They're usually also bigger, and you'll get more megapixels at the same time without compromising by also getting higher level of noise. Noise is kind of the graininess that you can sometimes see in images, especially in low light situations. And as a quick side note, by the way, you don't always have to use the biggest, most expensive cameras. A lot of times, I'll just take my daughter's little point and shoot camera. Like if we go to a vacation at an amusement park, I don't want to bring around 40 pounds of camera gear in my backpack and all of that. I'll just take her little point and shoot that I got her for Christmas. It's kind of funny that I got her the camera for Christmas, and yet I'm the one that always seems to be using it. Also, with these digital still cameras, one of the things that's becoming increasingly popular now is to buy single lens reflexes, or SLRs. That means that they're interchangeable lenses, basically. It also really refers to the way that light passes through the lens, through a prism, and then onto the film or sensor. But anyway, basically we call these SLRs, and they're generally larger, heavier, more expensive. They also give you a much higher level of quality, and they're more complicated to use. Novices with an SLR, or even with the cool pics that I just showed you, like that prosumer model, boy, there's a lot to learn in the manual and stuff like that, and a lot of times your users won't understand that. Now, that doesn't mean that as an A-plus technician, it falls on you to teach them photography or all of the menu systems within their cameras. However, you probably should be aware of some of the basics, at least, with some of these types of cameras. Again, they do have interchangeable lenses with a varying degree of quality, but overall, high quality. Some of them come with what we call kit cameras. So when you buy the camera, it includes one interchangeable lens, usually somewhere within the 17 or 18 millimeters up through maybe 55, maybe 70 millimeters, something like that. And they're relatively high quality compared to a point and shoot especially, but they're not going to be a professional level quality quite yet. For that, you got to spend a lot more money. There's also various focal lengths. And when we talk about the focal lengths in millimeters, a wide angle on a 35 millimeter format camera, or something like the common digital SLRs right now, a wide angle would probably be anywhere between 10 millimeters, which would be a fisheye. That probably gives you 180 degrees. And then it could go up to usually around 40 millimeters, would be a wide angle. So you might shoot things like landscapes or a big group of people or something like that in that range. When you go into 40 or maybe 50 millimeters, 50 millimeters is what you're supposed to be able to see with one eye closed. So this is an eyeball here. So just about what you could see if you covered up one eye. That's about a 50 millimeter field of view. Anything beyond that, you started getting into telephoto, starting at 70 millimeters. That's where you start to get a small level of magnification. And then at the top end of this right now would be probably 300 millimeters, or 3,000, 300 millimeters. I've got a 300 millimeter lens that I use to shoot sports and all. It's a very fast, good lens. It's one of those that you see photographers at football games use. That the big long ones, the big heavy long ones. These cost thousands of dollars, and nothing says you have to go to that. But mostly for your consumers, you're going to see something in these ranges down here. Now, a consumer level zoom lens might be 70 to 300 millimeters. It's not going to be at the quality of the fixed focal length 300 millimeter that I just described that we sports photographers use, but it does give you the same level of magnification. It just does not allow as much light in the aperture, and the aperture is an opening through the lens that will open or close to various ranges depending on how much light is in the room or in the situation. Also, these digital SLRs will give you much higher quality sensors than any of the other cameras that I showed you, and you get very flexible options. For example, one of the things that I'm able to do with my cameras right now is I've kind of gotten into astral photography. This means that I can set a camera up out remote portions of the desert and have it shooting photographs automatically all night and capture star trails. And then by way of example, here's what I was talking about, these star trails. I just set a camera on a tripod, let it go all night, and it created exposures all night long of these star trails going past the sky. And the way I illuminated these rocks, this is in northern New Mexico, by the way, was that I stood off to the side at the beginning of the process, and I fired off a flash unit manually to illuminate the rocks. And then I came back in the morning to pick up the camera and combined the images in Photoshop to show you this. But anyway, the kind of cameras that we use, the digital SLRs that I'm talking about here, gives you a lot of those flexible options. For example, I had to have a special timer that the camera was able to use to be able to photograph that kind of an event and so forth. And then finally, I want to show you this camera from Nikon. This is one of their flagship cameras, the Nikon D3S. The only reason why I'm showing you this is because, well, folks, my birthday just came and went, and none of you people sent me anything. I wanted to let you know that kind of did hurt my feelings a little bit, but I think you can more than make up for it if you just buy me this camera. Might sound like a lot of money at $5,000, but if you just start passing the hat and combine your resources, I think it'll be quite doable. In this nugget, we took a look at audio, video, and cameras. We started off by taking a look at audio and some of the additional connectors that we haven't looked at before, such as the optical cable and the digital coax. We took a look at video as well, such as the various display types you can use, which is really mostly a CRT as well as an LCD, although we also mentioned projectors. We took a look at the various connectors, such as VGA, DVI, and HDMI, and then some of the various terms that you might hear as well, such as resolution or degaussing and stuff like that. We looked at webcams so that you can see kind of how easy they are to at least set up and everything. And they can certainly be a lot of fun. And then we concluded with a discussion of digital still cameras, which are growing in popularity, and which I think you're going to find that a lot of your customers are going to have questions about. Well, I hope this has been informative for you, and I'd like to thank you for viewing.